Okay, and to end this, we just have an example where we're going to compute the average velocity. So this is just a straightforward using the definition. So we have a function that describes the position of a ball dropped from a 200-meter building. So this is our function right here. And we have that s is measured in meters, time is measured in seconds, and we want to compute the average velocity over these two intervals. So that will just be average velocity over the first interval from 4 to 5. We just take s of 5 minus s of 4 over 5 minus 4, right? And then we just plug in our values, or well, we plug in this value to our function. So 200 minus 4.9 times 5 squared. I'm going to put that in parentheses. And then 200 minus 4.9 times 4 squared. Right? And then 5 minus 4 is just 1. Okay, so I'm going to simplify this a little by hand and then just use my calculator at the end. So this negative, I'm going to want to distribute that. So I'll get 200 minus 4.5. 5 squared is 25, so I'm just going to write that as 25. Minus 200, and it'll be plus 4.9, and then 4 squared is 16, right? So I get this. And then this was over 1, so I can just write this without the denominator. Okay, now these 200s will cancel, and I will be left with, I'll write this one first, 4.9 times 16 minus 4.9 times 25, and then I can simplify a little bit further, so 16 minus 25. And then at this point I might want to stick this in my calculator, and if you do that, it'll be 44.1. And just so you know, like, I'm okay with you using a calculator for some of these calculations. I just think that the less complicated the thing you have to stick in your calculator is, the less likely you'll make a mistake, like dropping a parentheses or something like that, which will change the answer. So just to avoid, issues like that, I think it's good practice to just simplify before you stick it in your calculator. Okay, so this would be, we have meters per second, right? Okay, and then basically the same computation for the second interval. So this will instead be s of 4.5 minus s of 4, and then 4.5 minus 4, and that will give us 200 minus 4.9, we get 4.5 squared. 4.9 times 4 squared over 0.5, and I'm going to skip some steps in this computation, but basically we'll get 16 minus 4.5 squared, and that'll be over 0.5. And then if you stick this in your calculator, oh, I think I dropped a negative up here. This would be negative, right? Because 16 minus 25 would be negative. Okay, sorry about that. This one is also negative. We get negative 41.65 meters squared, meters per second. Okay, so if we wanted to, say, estimate the instantaneous velocity, we might do smaller intervals and smaller intervals, and if we were to see a pattern emerge, we might say that it's likely that the instantaneous velocity is some number. But I will have you guys do that in class, but I'm not going to do it as an example here. So just don't forget to take the comprehension check quiz before class, and then I'll see you in class.